Hello and welcome to Physics Problems 1 by 1.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So today's problem, it's very tempting to put 1 in our formula because it's 1 second, duration is 1 second, but I will resist the temptation. I will say t capital equal 1 second and I will solve it in characters and I will put t in the very end. So what we have some body starts from the rest, moves along the straight line with a constant acceleration a. And they're asking us, this is the duration t and it covers this distance. And then this is the same duration t, but it covers 3 times longer. So this is d1 and this is d2, and the time here is still t because it goes much faster, because it accelerates. And they tell us that d2 over d1 equals 3. And it starts here, but they ask us at what moment in time t should we observe this, so d2 over d1 would be 3. So again, we can draw a graph. We can say that this is v and this is t, and the body goes like that, and this is certain time t, and during this time body has some speed, and the speed already is at, and then it goes for the period of t and it gains more speed, and it goes for another period of t, and they tell us that this area is d1 and this area is d2. And of course we can draw a graph of x, and x over t would be that it goes, it's a parabola, and they tell us that it starts at that period of time and then it goes for the period t and it covers this distance. This is the distance. This minus this. And then it goes for another period of t, and the distance would be this. So this would be d2 and this would be d1. And they want us to find what should be this moment t, so d2 over d1 would be 3. So let's try to solve this problem. Of course we know, and they want us to write d1. d1 would be the speed at this moment, and the speed of this moment would be, let's put it v1. And duration would be t. I'm just writing. So d1 would be v1 over t, but t is the time that it moves. It moves for the period t capital, plus at squared over 2. All right. And then d2, so v1 is this speed and v2 is this speed, right? Its initial speed for the period of time is t, because remember this formula, d equal v0t plus at squared over 2. So v is initial. In this case, initial is v1 for this period of time. And time is duration of travel, and duration of travel is t. And with the second interval, the initial speed is v2. So I put it v2, but duration should be t capital, and it should be the same at squared over 2. So it's basically very similar formulas. The only difference is v1 and v2, because all other parameters are the same. But hopefully luckily we can find v1, because it starts from original position, and v1 it equals at. And accordingly, v2 it starts from original positions, but it travels t plus t. So we can add this, and we have 4 equations, and we should substitute this here, and we should write that this equals 3. And let's continue here. Let's remove this. And let's continue here. We have d1, and instead of v1 we write at. Multiply by t plus at squared over 2. Accordingly, d2 equals at, and I put at, and I multiply it by t, and I put at squared. I put this here and I open brackets, and this would be at squared over 2. And of course d2 equals 3d1, d2 equals 3d1. So I write instead of d2 I write this at2, and this plus this would be 3 at2 squared over 2. Because if I add this to this would be 2, 2 plus 1 would be 3. Or I can say 1 plus 1/2, it would be 3/2. So I wrote d2, and now I write 3 d1s. So I type 3 multiplied by this would be at squared, and then there would be 3 at squared over 2. Fantastic. D1, V1 equals AT, so this is ATT. Oh, this is a mistake, of course. When I was putting V1 here, see, it's very good when I make mistakes in the video, because then you see how I catch them and how I correct them. Because if I put this here, it would be AT lowercase t low by t. Now everything is good. So D1, that means ATT, okay, D2 is this, D2 is this, D2 is this, and the only thing here would be, let's untangle this, what I did. So this is correct, and D2 I write it as is. All I did, I added this and this, and then I write, okay, let's do it slower. 3 multiplied by D1, AT2 plus AT squared over 2, boom. And now I open those brackets and I have ATT plus 3AT squared over 2 equals 3ATT plus 3AT squared over 2. Gone, because those are the same, and it goes on one side, and we have 0 equals 2ATT. As that means t is what they're asking us. It may be possible only if t equals 0. So what that means, that t equals 0. So let me wipe it out, because we don't need it. We don't need this too. And let's verify this. Basically that means that t equals 0, so our graphs v, this would be t, and this would be t, and this would be time, and this would be v. So it tells us that this area is less than this area 3 times. And by the way, notice, it doesn't matter what t is it. T may be 2 seconds, 10 seconds, 1 hour. This area always would be 1/3 of this. It's very easy to prove. You can prove it, but I can give you an advice. For example, this rectangle is twice as this, and this is exactly like this. So this is twice as this, twice as this. So this area of this trapezoid is 3 times in this triangle. And the graph of x, it will start here, this period of time. It will cover this distance, and then it will cover 3 times more distance. Of course, that's all make perfect sense, because if we have that we start and we now know that it's in the beginning, so the distance, the first distance 1, it will become 80 squared over 2. And the total distance, d1 plus d2, will become a, and instead of t we should put 2t squared over 2. And this would become 4 times 80 squared over 2. So d1 plus d2 would be 4 times. d1 plus d2 will be 4 times of d1. And that means that d2 is 3 times bigger than d1. So what we got that no matter what time interval they give us, if we have this interval and the second interval is the same, and we start from the very beginning, this distance is 1/3 of this. Because this distance is actually, don't forget that this is d2, this is d1, and this is d1. So d2 is actually what we cover during this interval. Since the beginning of time, we cover d1 plus dt. So it all matches very well together, and the answer is very simple. In this first second, it covers some distance, and in the second second, no matter what, it will cover 3 times more distance. It may be 1 hour, it may be 10 minutes. In the first 10 minutes, moving with acceleration, it covers 1 distance, and in the next 10 seconds, same time, it should cover 3 times as much. As always, subscribe, bell, like, write a comment, ask the question, give me your problem, I'll try to solve it. Thank you.